Hello friends, in the previous video we spoke about creating the SSL sockets for the client side. In this video we will talk about creating the Keystore for the client side, and specifically we will talk, as I told you before, we will talk about these steps. This one for the key manager steps and this one for the trust manager steps. Okay, but first of all, let's understand, why do we need a Keystore? What is the Keystore? Why do we need the Keystore? How can we use the Keystore? And to understand these things, I have highlighted 4 points which can tell us about the Keystore. Now, what is the Keystore? The Keystore is just like a vault, a safe, where we can keep the security material such as the key material, the encryption keys, and the certificate material, the certificate. That's it. This is the meaning of the Keystore. It's like a vault, a safe, where we keep things inside it. The second point is, you remember when we said at the beginning that when the client wants to connect to the server and query to the databases, we need to create a socket, a connection between the client and the server, and this socket should be safe, secure. Now, once we created this connection, the client has to authenticate that this server is the intended server that the client wants to connect to, and is not a fake server or impersonated server. And likewise, the server needs to authenticate that this client has the right to connect to the server. So it's a bidirectional authentication between the client and the server. Now, to make this authentication process, we need the security materials that we spoke about. The key materials, which is the encryption keys, and the certificate material, that is the certificate. These things are stored in the Keystore. So this is the objective of the Keystore, that we will save these things inside it, and we will use them whenever we need to make the authentication between the client and the server. Now comes to the third point, which is an important one in my view. Now, when we want to create a Keystore, we have 2 ways. Either we use the Java default providers, or we use a custom provider such as the Bouncy Castle. Now, both ways I will show you. When we create the Keystore for the server, we will use both ways. We will create the Keystore from a Java default provider, and we will use the Keystore for the server using a custom provider, the Bouncy Castle provider. Now, when we instantiate the Keystore from the Java default providers, we just need the password. So the Keystore and the password to instantiate the Keystore. But when we want to instantiate the Keystore from a custom provider such as the Bouncy Castle, we will gonna use other parameters to instantiate the Keystore. So this is a big difference between both ways. In Java, we just need the password. In custom provider, we need other parameters, and we will see these parameters when we reach to that point. We will see what are the parameters that we need to instantiate the Keystore using a custom provider, such as the Bouncy Castle. Consequently, we will reach to point number 4, which is the outcome of point number 3. Now, when we use the custom provider, we're going to use some classes and interfaces that we will not necessarily use them when we instantiate the Keystore from the Java default provider. So this is the point number 4, is that we will use, when we use the custom provider to instantiate the Keystore, we will use some classes and interfaces that not necessarily we will need them, and we will use them when we create the Keystore from a Java default provider. And for instance, you remember when we said when we need to initialize the SSL context, we need 3 things: the key manager, the trust manager, and the secure random. Look here, when we use the custom provider, we're going to use these classes to get a key managers, to initialize the key managers, which will give us the key managers. While in the Java provider, to initialize the key manager factory, we just need the Keystore with its password. That's it. While here, when we use the custom provider such as the Bouncy Castle, we're going to use these class interfaces all the way to reach to this point, and from which we will get the key managers and we can use it in the SSL context. And likewise, when we want to get the trust managers from the trust manager factory to initialize it, as we have said in the presentation at the beginning, at the first video, the previous video, we said that if we have only one CA, we just need the Keystore. Remember that when you initialize the trust manager, you don't need a key password, you just need the Keystore. It's not like the key managers. And or if we have multiple CAs, then we need to go with all this way, which is this way. So if we need to get the trust managers, we need to initialize this trust manager factory. If we have one CA in the Keystore, we go directly. Or if we have multiple CAs in the Keystore state, then we need to assign one CA in particular that the server will use it to authenticate the client. So we have to go through all these classes and interfaces to initialize the trust manager factory from which we get the trust managers. So now you might wonder, why do we need all this headache? Why do we use multiple classes and complicate things? Remember in point number 3, we said that when we need to initialize the Keystore, we will go on to use other parameters. These other parameters will give us the flexibility to control the creation of the Keystore. For instance, in Java default, we can say use only the PKCS12 type of Keystore, but when we use these classes with the Bouncy Castle, we can use another type, a more advanced type, such as the BCFKS type of Keystore, which belongs to the Bouncy Castle. So we will control the creation of the Keystore, which could give us more strength to that Keystore by taking other type of Keystores, and also it will give a flexibility to use this Keystore with different platforms. And after we create the Keystore and initialize it, we will see and we will learn how can we load the entries such as the keys and such as the certificates inside this Keystore. Now these steps you can see here for the key managers. I have depicted them and created them in the application step after the other. It's like this. First, create store builder. You can see here the store builder, then the store builder parameters, then the manager factory parameters, which is all step after step, method after method. Store builder, store manager factory parameters, then the create the store, and eventually we will get the key managers, which is the end of it is this one in here. And same as well with the trust managers. We will see how we can use these ones if we need them. Okay, having said that, let's see these methods. Now, to make things easier for you, I have created this method and put them in this utility class, each method in here, just to make it more easy to read, more readable way. This is number 1. And number 2, from now on the things will get a little bit complicated, so I wish that you give more attention and more focus on the steps, because any mistakes when you do these steps, either it will lead to that you cannot create the Keystore, or if you create the Keystore, maybe it will have some deficiencies which will make it not work properly. So please focus on these steps, coming steps. Okay, so let's start with the first method to create the Keystore builder. This is the method to create the Keystore builder. And the purpose of this static method is that we get an instance of the Keystore builder. Now we need to understand what is the Keystore builder. The Keystore builder is just a place where we keep the parameters that we will use to create the Keystore. That's it. So you remember when we said that when we use a custom provider such as the Bouncy Castle, we will use other parameters other than just the password. So we need to keep these parameters in one place. we encapsulate them, and we keep them in one place. The Keystore builder is that place, is the class that will take these parameters, put them in one place, so later on we can use these parameters to create a Keystore using the getKeystore method. This is the method that will create the Keystore. Once we call it, once the instance of the Keystore builder call this method, then we will get a Keystore. So the Keystore builder will not give you a Keystore. It will just encapsulate the parameters that we will use to create the Keystore. And when this instance of the Keystore builder call this method, at that time only we will get a Keystore. Now there are two types of Keystore builders. We can initialize them. One takes 4 arguments, one takes 3 arguments. The difference between them is the file. In the first argument we will use the file. The file is the seed file that we have created at the beginning. If you remember, we said that we will create a binary file to use it as a seed for the Keystore. Other than that, the parameters are the same. Here is the type of the Keystore, here is the provider name, and here is the password of the Keystore. The same thing in here. So let's see what are these two methods and how we can implement them. These are the two methods. One takes 4 parameters, one takes 3 parameters, where we can use each one of them. Now, remember when we said that the Keystore instance, Keystore builder instance, call a method getKeystore, which can create a Keystore instance. Now, if we use this instance of Keystore builder and we call the getKeystore method, we will get one object of Keystore. This Keystore object will remain the same every time we call this method or every time the server restarts. The Keystore object will never change, and subsequently whatever data inside it will never change. I mean, it will be updated, but it will not be deleted or new ones. So that if we get a Keystore builder instance, we call this method, we will get the first call to the getKeystore method. We will get an object of the Keystore, and that object of the Keystore will remain the same, it will never change. On the other hand, if we use the Keystore builder instance from the second method, which takes 3 arguments only, and we call the getKeystore method, we will get a new Keystore object every time we call this method or every time the server starts over. We'll get a brand new, an empty Keystore every time we call this getKeystore method. This is the main difference between these two methods. Here we get one object of Keystore at the beginning, at the first time we call this method. That object of Keystore will remain the same. It will never be changed. Here we get a new object of Keystore every time we call this method. Now, supposedly we can use this type of method if we need to change the Keystore file for whatever reason. You want to change the Keystore files frequently, then you could go with this method. I will go with this method, by the way. And if we have the time, we will go with this method as well, but the difference is not that big. So this is the main difference between these two instances of the Keystore builder when we call the getKeystore to get a Keystore object. Okay, now let's talk about the parameters. Either 4 parameters or 3, they are the same except for this file. This is the provider, which Bouncy Castle, the custom provider. This is the file that we have, the binary file that we have created at the beginning, and we said we will use it as a seed for the Keystore. And this is the password. The password, we will use this Keystore static method password protection, which you can find the details about it, the Keystore password protection, and the constructor of it, which takes only a character array, a password, a normal password, a character array, and a character array, you could use it in an auxiliary class, let's say, like this one. You could put these whatever extra data you want to use. So this is the password protection method, which takes a character array or the password, and you can use its instance in here. Now we comes to this part, which is the most important part. Now Bouncy Castle takes two types of Keystore, either BCFKS or PKCS12. Now there are some differences in both of them. The BCFKS is specifically designed to work with the FIPS mode. So it is specifically was designed, this type of Keystore, to handle the FIPS mode. The PKCS12 is somewhat not that much compatible with the FIPS mode. You can find good details about the two types of the Bouncy Castle Keystore in this article, which I highly recommend you go through it. It's a very important article, and at the page number 56, I believe. Yeah, here you will see the main differences between the two types, the BCFKS and the PKCS12. There are some differences, and important differences actually, so you need to go through this article so you can find what are the differences and which type of Keystore will suit your needs, so you can use it in this. And again, there are good differences and important differences between the types BCFKS and the PKCS12, so you need to be careful which one to choose and which one to implement with your application, so you could get a Keystore. Now in my case, I'm going with the BCFKS because it's more compatible with the FIPS mode, and as well as I'm going with the second method, which this one, to create the Keystore. Now this is all about the Keystore builder. Once we have done this, that means we have got our instance of the Keystore builder, which will later we will use in other methods. And now we go back to the second method, which is after the Keystore builder. The second method is create Keystore manager factory parameters, which is this one, exactly after the Keystore builder. Now this class, the manager factory parameters, and this method, this static method, will gives me an instance of this manager factory parameters. More specifically, the Keystore manager factory parameters, using this class, the Keystore builder parameters. Now this instance of the manager factory parameters, we will use it to initialize the key manager factory, which means that this instance providing me information needed to initialize the key manager factory. Now let's understand what is this manager factory parameters instance. Now the manager factory parameters is just an interface which provide information to the key manager factory or the trust manager factory. Especially when we use a specific algorithm, this information that we provide to the key manager factory or the trust manager factory are essential to initialize the key manager factory or the trust manager factory. This is the whole point. Now how we do that? You remember when we said we use a custom provider use parameters, we encapsulate them in a Keystore builder. This Keystore builder, which encapsulates the parameters, we will use it in here using this class. Okay, this is the whole point of the manager factory parameters. Now, why we do this? For what? This class, which is this one, encapsulates parameters only if they are of type X509. So this class encapsulates the parameters which are saved in the Keystore builder, but only if they are of the type X509. Remember when we created the keys and when we created the certificates and the encryption keys, they were of type X509. So this class encapsulates these parameters because they are of type X509. This is number one. Number two, this class also, the constructor of it can use either one Keystore builder or two or a list of Keystore builders. So in my case, I have created one Keystore builder only. So I'm using it here in the argument. But if you have created multiple Keystore builders, then you should put them in a list and then again use that list here as an argument in here. So you can use it to create the Keystore builder manager factory parameters instance. And afterward, you can use it as an information supplied to the key manager factory to initialize it. Now, if you need to know what are these parameters, you could use this method, the Keystore builder parameters. In this instance, you can call get parameters, and it will give you the parameters that you have used to create the Keystore builder, which should be these things actually, because these are the parameters that we have used with the Bouncy Castle custom provider. And by doing so, we have created an instance of this one, and we have used it to initialize the key manager factory. Now the next step is that we need to create the Keystore and the create certificate, which are these two static methods: create Keystore and afterward create certificate factory. Okay, now this method, the static method, the create Keystore method, we will create the Keystore obviously using the Keystore builder instance, calling the get Keystore. Only now we will have a Keystore. Now once we have created the Keystore instance, now we need to load whatever data in it by reading the file that we have created, the binary file. Now we will use an ASN1 input stream in this case, because this is more specific used with the Bouncy Castle. Remember that when we read this file, we have two ways. Either the file contains data or it doesn't contain data. Here, when we created the Keystore builder, we said that we have two ways. We create from this method or from this method. Now, since this method creates new Keystore builder, which has no data inside the Keystore, that means we will get this load method, which has null inside it. So the input stream in this case is null because there is no data coming from the file, basically, because it's a new Keystore, new create Keystore, empty Keystore. So the input stream in this case null, and in this case we will get a Keystore that is empty Keystore. We just use the password of it. Now, if on the other hand, if you use the Keystore builder of this one, which will give you the same Keystore every time, which has data in it, in this case you need to go with reading the data in it, converting them to byte array and using them as an input stream when you use the load method with the Keystore. But remember one thing, you need to make the check, the end of file exception check. Each input stream, if the input stream is less than 8 bytes, it will give you an exception, the end of file exception, EOF exception. So you need to make this check. If it's bigger than 8 bytes, then you can read the data and load them in the Keystore. This only if you use this method. But since we are going with this method now, so there is no data inside, because there's a new Keystore builder, an empty will give us an empty stream, empty input stream. So we'll use the input stream argument as null, and in this case we will get a Keystore that is totally empty. You could use these two methods for if you wish, and they will give you the type of the Keystore that you have used and the provider name, just for your information if you wish to use them. Now once we have done these steps, that means we have created our own Keystore and it's ready to be used. The other option is that we need to create the certificate, create certificate. This static method, create certificate, will give us an instance of the certificate factory. We will use this certificate factory to convert the certificates into the X509 type of certificates, so we can use them and store them in the Keystore later on. This is the whole point of the certificate factory. We just need to use this class, call this method with this type of certificates, so we can convert them and get certificates of this type. These are the two things that will hold with this methods. Once we have created the Keystore and the certificate factory, then we will start saving the security material, that is the key material, the encryption keys, and the certificate material, the certificate inside, one each at a time. When we use the key managers, then we need to save only the keys, because the key managers focus on the keys only, and while the certificates, we will save them when we go with the trust manager, because the trust manager deals with the certificate. So from now we will start calling this method to start the client key. Now with this static method of the storing client key, let's have a look first about what things are we need to make the bidirectional authentication. You see, on the application side, we need to store in the Keystore of the application three things must have: client key, client certificate, and intermediate certificate. While on the server Keystore, we could have all the certificates and keys that we wish to save in: server certificate, trust chain cert, intermediate cert, client key. So why is that? These two things, the client key and the client certificate, we must have them in the application Keystore because the server will use them to authenticate the client. On the other hand, this intermediate certificate, we should have it in the application Keystore because the client will use it to authenticate the server in conjunction with the trust chain certificate. So these things must have at the application side Keystore. Now, having said that, let's start one by one. Let's start by having the client key, then we store the client certificate, and then we store the intermediate certificate. The first thing is that we need to store the client key. Now, how we save these things? Using what? In the Keystore. We use this method, set key entry. Let's have a look at the Keystore. Now, I highly recommend that you go through this class because it will give you a good insight about the Keystore. But in brief, if we go down here, if we want to use save and store the entries, the keys, and the certificates inside the Keystore, we have to use one of two. Either set key entry or set certificate entry. Set certificate entry will save the certificate. Set key entry will save the keys, obviously. Now, since now we are focusing the first step to storing the key, then we have to go with this method, set key entry, which will take this argument, an alias, a byte array, or the certificate chain. Or there is another option for the same method, but it will take a key. Instead of a byte array, it will take a key. Now, what is the difference in these two cases? What is the difference? Both will save a key, an encryption key. So why this difference? The difference is that if we use byte array, that means the key that we're going to save is encrypted with a passphrase. So we should have a key, or the byte array of the key, encrypted with a passphrase. On the other hand, if we go with this method, using the key and adding a password to it to store it in the Keystore, then this key should not be encrypted. We can add a password to it when we add it into the Keystore. But the two types are different. Here we use a byte array, here we use a key. So you need to make sure which one is suitable for you. If you have a key that is passphrased, encrypted, then you go with this one. If you have a key that is not passphrase encrypted, then you go with this one, and you should assign a password for it before you store it in the Keystore. So I'm using this one. I will go with this one. Remember that if you go with this one, you need to decrypt or remove the password before you use it. So I'm going with this method, set key entry, which I will get a key and give it a password to store it in the Keystore. Now here you need to give attention to one thing. This key, suppose that you want to save the server key or the intermediate key. You will save only the private portion of the key, only the private portion, because the key has a private portion and public portion. What you need to save in here, in this here, you should extract only the private portion of the intermediate key or the server key or the client key, whatever key, only the private portion of the key, so you can save it here, give it a password and save it. One more thing important, since you are using the private portion of it, you must have a certificate array to authenticate that this key have been signed and trusted by the intermediate and the root certificate. And I will show you the meaning of it in a while. Let's go back to the code. This is the Keystore.set key entry. First, we give it an alias name, just like a label name, a reference name for the key, which you can use it later on. Here is the private key, but the private key in this case is the private portion of the client key, because now we are saving the client key. So this private key is the private portion of the client key. And I will show you how you can extract the private portion through these steps. And then you give it a password, whichever passphrase you wish. And here the client chain certificate. This is a very important, you have to add it because you are using a private key. Only you choose a private key, private portion, then you have to use this one. And the way you can get this one, basically what is this one? This client chain cert, it's the client certificate concatenated to the intermediate certificate and the root certificate. These three things must be concatenated to each other and used in here. If you just use the intermediate certificate and the root certificate, you will get an exception. an exception telling you that the RSA signature is different. So you must here, when you add the client key to your application key store, when you use the private portion of the client key, you must have the client chain certificate, which is the client certificate concatenated to the intermediate certificate and the root certificate. Give attention to this point. Now let's get these things step by step. Now this is the client chain certificate, which is, I have stored it on the source, the client chain certificate, as you can see here. This is, I have stored it on the source file, the source class path of my application. Now I need to read it using the file reader and change it to a buffered reader, so I can get an object of the buffered reader. And this I need to make mark supported. It is important to make a mark supported. Why? Because these are three certificates concatenated to each other. So you need to know when one certificate start and end, when the other one start and end, when the third one start and end. By doing mark supported, you will use the mark method to mark each certificate, when it start, when it end. Next step is that, now remember that we are still working on this one, on this. So far we are working on this. We still didn't work on private key. Private key is another issue, is here. But we are working on this side now. We are reading the client chain certificate. So once we have got our buffered reader of this client chain certificate, we need to use a special class by the name of PEM parser, which is specially designed for the Bouncy Castle to parse the certificate. And you can get an information about this on this article, the PEM parser, the class PEM parser, and what it do, and how it can read the certificate, what can read the keys, and also the PKCS7 objects. It also can read, so it can read, it can parse all the X509 certificate, the PKCS8 keys, encoded keys, and the PKCS7 objects. So it's a good class to use to parse any and read any objects. Now this will give us a PEM reader object, a higher object from the PEM parser. This client key PEM reader, we will read this object one after the other, which give us a PEM object. Now you need to focus, as I have said before, you need to focus because the steps are a little bit tangled with each other, so you need to get a little bit focused. This PEM object, we use it to get the content of this certificates as a byte array. Once we have got the byte array object, then we use it as an argument to get an input stream. Why we do all this? Because this certificate, we need to get a certificate array. The client chain certificate, it should be a certificate array. Remember in here, in the Keystore, this should be a certificate array. It's not a normal certificate. So we need to convert these chain certificates into a certificate array. So we need an input stream. Now this input stream, we use it to generate a certificate from the certificate factory. And then we add them together and then get the size and we convert them into an array. And this is how we will get the client chain cert, which we will use it as the third argument when we set the key entry. And we have to do this because we are using a private key, the private portion of the client key. We have to use this. So this is the way how you could get the client chain cert. First, you concatenate the client cert to the intermediate cert to the root cert, put it on your class path of your application, read it, buffer read it, mark supported, PEM parse it, get the PEM reader, from the PEM reader read the object, get a PEM object, get the content of it, make it as a byte array, use it as an input stream, as an ASN1. From this ASN1 input stream, you use it with the certificate factory to generate a certificate, and from which you could turn it into a byte array, a certificate array, which finally you can use it in here. I'm trying my best to simplify the things so you don't get lost among all these steps. Now comes to the other argument, which is the private portion of the client key. Remember, we are saving now the client key in the Keystore, in the application Keystore. Now this argument, the private portion of the client key, we will get it like this. Now this is the client key. I name it PostgreSQL key. You could name it whichever name you wish. Also, you put it on the source of your class path, or the source path of your class, of your application, and you read it using the file reader with buffer reader, and also use the PEM parser. From the PEM parser, sorry, use this PEM parser object to read this object and cast it to a PEM key pair. Cast it to this class, the PEM key pair. This class is like a holder of both the private portion and the public portion of the key, of this key. This holder instance, use it to get a private key info for the private portion and public key info for the public portion of the key. Once you have done this step, then the next step is that you use this class JCIPN PEM key converter dot get private key, and use this private key info as an argument, and here you will get the private portion of the client key. Likewise, if you want to get the public portion of the client key, use the same class get public key, use this subject public key info as an argument for the public key, and here you will get a public key. Although you don't need it, you will not use it, but it's just for your information how you could get the public portion of the key. Now, since we have got the private portion of the client key, now we could use it as an argument, and we can give it a password, whichever password you wish, and then we can store it in the Keystore. Again, recap how we can get the private portion of the private key, of the client key. The key, the client key, we save it in our application class path. We read it using the file reader and buffer reader. We parse it with the PEM parser. The object of the PEM parser, we read the object. We cast it to a PEM key pair, which is a holder for both the private portion and the public portion of the client key. We get the info of the private portion and the info of the public portion. Then we convert it to a private key using this class get private key, and we use as an argument the info of the private key, and for the public key likewise we do, though we don't need this public key to use, but for your information. Then we get this private portion of the client key and we use it here as an argument, and we give it any passphrase you wish. This is the entire process how you could store the key into the Keystore. One more thing, if you want to move the Keystore, transfer it to another place for whichever reason, you could go with this method, store and you make as an output stream, this Keystore you make it as an output stream and give it a password, and then you can transfer it to another place that if you wish to store it. And the way to do that is pretty easy. If you wish to move the Keystore to another place, you just byte array output stream. So let's say BAOS client new byte array output stream, and then you could use the Keystore.store, and here you will use this output stream and give it a password. So when you move this Keystore to another place, you should protect it with a password as well. And BAOS client and some password, whichever password. It should be a character array, of course. And let's say X values Keystore password, for instance. That's it. That's if you wish to move the Keystore to another place, you put it in an output stream, and then you can move it, protect it with a password, and transfer it to another place. Okay, so this is the entire process of how you can save the client key in the Keystore. Now there are more into this work, but I'm trying to simplify the things because there are other options how you could save them if you use a byte array output stream or IOU tools or BAOS. So there are a lot of into this process, and as I said, I'm trying my best to simplify these things. But this is the basic way to save and store the client key into the Keystore. Now once you have done this, so this method which is completed, now we can use it and process it. Once we have stored the client key, then we can go with the last step to get the key managers, calling the factory, calling this get key managers, and here we will get the key managers, which is the first argument when we want to initialize the SSL context. Now once we have done this, now comes the next method, which is the trust managers. Now we will deal not with the keys, we will deal with the certificate. We will save certificate in the Keystore. That's why we will deal it with the client trust manager. And this method, we will see it in here. Now the steps are almost identical to the key manager. We need to get an instance of the factory, trust manager factory. We need to initialize it, and then we get the trust manager. The steps are 3 steps identical. The difference here in the implementation of how we do that. Other than that, the 3 steps are almost identical. Get an instance of the factory, trust manager factory, initialize it, then use it, call this method to get the trust manager. Now how we will implement, that's what we will talk about. Now when we create the trust manager factory with the same algorithm, with the same provider, now here the difference is we could go 2 ways. As you have seen here, either we use one this way to initialize the trust manager factory, or we go with this lengthy, complicated way to initialize the trust manager factory. This way, if we have only one certificate authority saved in the Keystore. This way, if we have multiple CAs stored in the Keystore, therefore we should assign, we should look where is the path of that cert CA that we need to use so that the server can use it to authenticate the client. So this here is about finding which CA that we will use in the Keystore if we have multiple CAs. But here we have only one CA saved in the Keystore, so it is directly we can use the Keystore to initialize the Trust Manager factory. And it is shown in here. If you have one CA, immediately use the Keystore to initialize it, and then once you initialize it, call the get trust managers and get the trust managers. The trust managers, as we have said before, it's a vault to save one type of certificate material, that is the certificates. So this is what we should do when we want to create the trust managers if our Keystore has only one CA. Now, if your Keystore have multiple CAs, then this is a totally different story, and I will go through it in brief because it's a little bit complicated and might deviate you from the track. But first, let's see how we can save a certificate in the Keystore. So for instance, we have two certificates. We have the client certificate and we have the intermediate certificate that we need to save. As we have said before, we need three things. We need the client key, which we have already just now saved it. We need the client certificate and we need the intermediate certificate. So these two, we need to store them now in the Keystore using the Trust Manager. So this is the methods, which are two methods, one for storing the client cert and one for storing the intermediate cert. Let's go one by one. The process to store a certificate is pretty straightforward. It's very easy. And we can see that it's in here. To store and save a certificate in a Keystore, you just use this method. Use the Keystore object, use this method, set certificate entry, give it an alias to the certificate, a reference name and a label name, and then add the certificate. And the way to do that is pretty simple. This is the client certificate, which you have to place it on the class path of your application, read it using file reader, buffered read it. Now, since it's only one certificate, apparently you don't need to make a mark support, but I advise you to use the mark support so you could mark the start and the end, although it's just one certificate. But it wouldn't hurt you if you use this mark supported. Now, once you have got the buffered reader object, you parse it using the PEM parser class. You convert it to a higher object, the PEM reader. This PEM reader object, you read the object, which is this one, which will give you a PEM object. And this PEM object, you get the content of it, which will give you a byte array that will use it as an input to get an ASN1 input stream. And this one, you will use it as an input to generate a certificate using the certificate factory. Once you got here, this is the certificate, you can use it in here. That's it. That's the whole process of saving a certificate in the Keystore. Now again, if you wish to the same thing, if you wish to transfer the Keystore, the entire Keystore to anywhere else, you can use the same what we have done before. Now this is for the client certificate. Now let's see about the intermediate certificate, how we can save it. It is exactly the same. This is the intermediate certificate. We place it on the class path, read it, buffered it, mark it, PEM parse it, PEM read it, read the object, get a PEM object, get the content, byte array, use it input to the input stream, and then use the input stream as an input to generate a certificate, which is this one, which will give you a certificate that you will use it in here. In Keystore.cert certificate entry, give it an alias, and the certificate. That's it. That's how you will save any certificate in your Keystore. Now, with these 3 steps, now we have client key, client cert, and intermediate cert. All 3 basic ones, must-have ones, saved in the Keystore of your application. Now, let's see back. We said if we have one CA, in this case, in our case, the CA is this one, is the intermediate, because this is the certificate that sign and trust all other certificate on behalf of the root certificate. So this is the one CA that we have now saved in the Keystore. That's why when we initialize the Trust Manager Factory, we just use it directly, the Keystore, to initialize it. Now, on the other hand, if we have multiple CAs that we want to store in the Keystore, in this case, we need to pinpoint which CA that we need to use it when we authenticate, when we make the bidirectional authentication of the client and the server. And that thing is that we need to get the path of that certificate within the Keystore. And the way to do that is a little bit lengthy, but I'll go through it just for your information, but you need to double check it more. And the way to do that is that you need to create a manager factory parameter. This is the method, trust store MPF. You need to create manager factory parameters, create store MPF. Now this one will take, if the Keystore is not null, of course, it will get a cert path trust manager, which take a PKIX parameter, which takes a Keystore eventually. Let's go step by step. Remember when you said the manager factory parameters, one of them is for the key manager, which is the information to the Keystore, to the key manager factory or to the trust manager factory when we have a specific algorithm used. Now, if we have multiple CAs in the Keystore, we need to, as I said, pinpoint which CA we need to use for the authentication. We should find the path of it. To find the path of it, we have to go with this class, cert path trust manager parameters, which is this one. Cert path trust manager parameters. Now, all these class which you will see now is just to pinpoint the path of that CA. And from there, we will go to cert path parameters, cert path parameters. This cert path parameters, we will go with this PKIX parameters. Why? Because we are using a PKIX algorithm which is of type X509. Our certificates, our keys were made with type X509. The PKIX, as we have said before, it's also of type PKIX. So I need to go with this PKIX parameter. This is all about finding the path. So all these classes that I'm showing you now, whether it's the cert path trust manager or the cert path parameters or the PKIX parameters, these all we will use it just to find the path and validate it of that CA that we need to use it. That's it. That's the whole thing about all these classes, is to find the path. And the way to do that, as I have shown you in here, the first step is that you need to the cert path trust manager parameters, which takes a PKIX parameters, which takes a Keystore as an entry, as it says here. The PKIX takes a Keystore, of course, because eventually we need to find the CA in that Keystore, which CA we need to use in that Keystore. So the PKIX parameters Keystore takes an argument of a Keystore. And this is the first step, by the way. Now, if you go with this details, you need another steps, which will choose which CA you will select, and then you will add other parameters, the policies to the object of the PKIX parameter, and then you have to validate it using the cert path validator.validate. And once you have validated, that means this CA has been chosen, and you can use it to generate or to initialize the trust managers. It's kind of complicated. If I go through it step by step, it will definitely take you away from the road. So I didn't go through it, all of it. It's just an idea how you can do it. This is the basic idea, and then you add the policies, and once you add the policies, the next step you add the policies. The third step is that you need to validator.validate to validate the path, and then you can use this instance in here to initialize the trust manager. Now, since I have only one CA in my Keystore, in my application, then I don't have to go through all that path. Now, once we have initialized our trust manager factory, now we can call this method to get the trust managers, and by getting the trust managers, that means the second step has been completed, and what we need now is to initialize the SSL context. Now, for the initializing the SSL context, we spoke about in the previous video when we created the SSL socket for the client side. So far in this video, we talked about creating the Keystore for the client side, for the application side, within these two parts. And by doing so, by creating the Keystore for the client side, we have finished this part, the application side part, the client side part, by creating an SSL socket and a Keystore for the client side. In the coming videos, we will talk about creating the SSL sockets with multi-threaded, and the Keystore as well for the server side. Thank you very much.